All right, adding and subtracting polynomials. In this first example, we're going to subtract this polynomial here from the first one. Okay, now to subtract the polynomials, we have to drop these parentheses. Okay, but first, before I drop the parentheses on the second polynomial, we need to distribute this -1 in there. So we have 5 plus 5n cubed. Now this -1, it's getting distributed in like this. So we have -1 times 1. Okay, -1 times 1 gives us -1. We have -1 times -3n cubed. Okay, this is an entire term, -3n cubed. So -1 times -3n cubed, that's negative times a negative. It gives us a positive 3n cubed. Okay, it's kind of like this. If you have a minus, let's say 5x plus 2, okay, that basically what you have here is a -1. It's -1 being multiplied by all this stuff. Okay, it's kind of an invisible, the 1, we don't always write it in, but you just kind of assume that's there, right? Because anything times 1 is itself. So basically what you're doing is you have -1 here and you're distributing it in this way. Okay, so if you ever see a negative sign there, it's there's a -1. Even if you don't, let's say you have 2x minus 3. Okay, there's a positive 1 here out in front. It's just invisible. We don't write it in. You don't need to, right? You don't need to write that in because anything times 1 remains itself. So there's always an invisible 1 kind of. I know it's kind of strange. You kind of got to get used to this idea. But there's just take my word for it. There's an invisible 1 here whenever you see a negative sign like this. Okay, and then it has to be distributed in. We're distributing that in. So we did that here with this top one here. We took this -1 times +1 gives us -1. -1 times -3n cubed gives us +3n cubed. Okay, now at this point we can drop the parentheses on this one. And we're not distributing anything in, right? There's just a +1 out in front. So if I distribute a +1, everything kind of remains the same. So you only really need to do this distributing in when you have a minus sign. Okay, when you have a minus sign, you have to do this distribution. So now we could just say like this. We could say 5 plus 5n cubed minus 1 plus 3n cubed. Okay, now we're going to do like terms. So we have 5, -1. We have 5n cubed and a 3n cubed. So 5 minus 1 gives us 4. 5n cubed plus 3n cubed gives us a +8n cubed. Okay, to do this matching terms, what's important is that these variables are the same and that the power is also the same. Okay, n cubed, we have 3n cubed. Here we have 5n cubed. Okay, that's like saying 5 apples plus 3 apples, but the apple is an n cubed. Okay, so we're when you're doing like terms, when you're combining like terms, it has to be the variable and the exponent has to both be the same in both cases. So here's the answer for the first one is 4 plus 8n cubed. All right, problem number 2. Here's our two polynomials, 6 minus 3a squared plus 2a squared minus 3a. Now, like I was just saying, that the only time you really need to distribute something in is if you have a negative sign, but here we have a positive sign. If you have a positive sign, you could just go ahead and drop the parentheses. Okay, if you think about it, if I distribute, let's say I have a +1 and I want to distribute +1 in there. Well, it's going to be the exact same thing, right? 1 times 2a squared is just 2a squared. 1 times -3a is just -3a. Okay, so you don't really need to do any distribution when you see a positive sign. Okay, when you see a positive sign like this, you could just go ahead and drop the parentheses. Same here, same with this term. If you don't see anything out in front, you're going to assume that it's positive. Okay, the only time you're going to distribute is if you have a minus sign. So we could go ahead and drop these parentheses. And this is what we get. Now we're going to do combine like terms. And it looks like the only two like terms is the 3a squared and the 2a squared. Okay, like I said earlier, that the variable and the exponent both have to be the same. Okay, so 3a squared, 2a squared. Okay, this is just 3a. This isn't 3a squared. This is 3a. So this is a different. This is different. This isn't similar to these. These are the only two that are similar. So we have 6 minus 3a squared plus 2a squared. That's basically minus 3 plus 2. It's going to give us a minus 1a squared. Okay, and then minus 3a. So we could just call this 6 minus a squared minus 3a. Okay, or maybe your teacher likes you to write it in descending order, so it would be minus a squared minus 3a plus 6. Okay, x squared minus x plus 8x minus 2x squared. Once again here we have a positive sign, so these parentheses we could just drop them off. Same here, if you don't see a negative sign, okay, if there's a negative sign you'd have to distribute it. But we don't have that. Okay, if there's nothing out in front, you're going to assume that that's positive. So that means we could just drop these parentheses right off. We could just drop them off. So we have x squared minus x plus 8x minus 2x squared. Combining like terms, here's our like terms, x squared minus 2x squared minus x plus 8x. Okay, so x squared minus 2x squared, that's going to give us a negative 1x squared. Minus x plus 8x, that's going to give us a positive 7x. So here is our answer, negative x squared. You don't have to write negative 1, you could just call that negative x squared plus 7x. This kind of goes back to what I was saying, that there's always an invisible 1. Okay, if you just see negative 1x squared, it's the same as negative x squared. Okay, you don't always have to write this number 1 in. Okay, just like I was saying, there's an invisible 1. There's an invisible 1 here. We just don't write it in because you don't need to. Okay, so there's our answer for the third one, negative x squared plus 7x. All right, 2a squared plus 4a cubed minus 3a cubed plus 8. Now, we have to distribute this negative 1 in. We have to distribute in this negative sign. So, once again, if you don't see anything out in front of this polynomial, if there's nothing out front, you could just drop these off. Okay, the only time, like I said, the only time you have to distribute is if there's a negative sign. You have to distribute that negative sign in. Basically, what it's going to do when you're distributing a negative sign is it just changes the sign of everything out in front. Okay, whatever's positive turns to a negative. Okay, whatever's negative turns to a positive. That's what happens when you have a negative sign. It just changes the sign of everything in front. So here's what we have. We have 2a squared plus 4a cubed minus 3a cubed. Okay, that's that one. Minus 8. Combining like terms, we have 4a cubed minus 3a cubed. Okay, those are the only two terms that are alike. So now we have 2a squared, okay, plus 4a cubed minus 3a cubed. Okay, that's just going to be a plus a cubed plus 1a cubed. 4 minus 3 is 1 plus 1a cubed. Like I said, you don't have to write that number 1 out there. Okay, minus 8. Put that in descending order. You have a cubed plus 2a squared minus 8. Okay, here's our answer. All right, 5x squared plus 4 minus 5 plus 5x cubed. Once again, we have to distribute this negative sign in. So this first polynomial, we could just kind of drop the parentheses around it. Okay, negative 1 times 5, that gives us negative 5. Negative 1 times positive 5x cubed, Negative times a positive is a negative, so we have negative 5x cubed. Okay, combining like terms. Seems that the only like terms are these two right here, 4 and negative 5. Okay, we can't combine this and this because it's different. This is saying negative 5x cubed. This is negative 5x squared. Okay, x squared and x cubed are not the same. So we can't combine these terms, but we can combine these two. So 4 minus 5 is negative 1. Okay, negative 1. Plus 5x squared minus 5x cubed. Okay, putting that in descending order. And what I mean by descending order is you're going to take the highest polynomial, the highest exponent, whichever term has the highest exponent, and it's going to go out in front. So we have negative 5x cubed plus 5x squared minus 1. Here's our answer. All right, 10p cubed plus 11 minus 11p plus 13 plus 16p squared. Now this first one, we could drop these parentheses right off. So we have 10p to the fourth plus 11. And once again, when you distribute a negative sign into a polynomial like this, what it does is it's going to change all the signs to the opposite. So here we have a positive 11, positive 13, positive 16p squared. Okay, it's just going to switch the signs out in front. Okay, so here we had a positive 11p. Now we have a negative 11p. Okay, here we had a positive 13. Okay, now we have a negative 13. Here we had a positive 16p squared. Now we have a negative 16p squared. Okay, when you distribute a negative sign in, it's going to switch the signs. That's what it does. It switches all the signs. Okay, now we can combine like terms. Seems that the only two like terms is positive 11 and a negative 13. All right, so we have 10p to the fourth. And positive 11 minus 13, it's going to give us a negative 2. Okay, and minus 11p and a minus 16p squared. Now we're going to put that in descending order. So we have 10p to the fourth minus 16p squared minus 11p minus 2. Okay, that's our answer. All right, next problem. Here, this first polynomial is positive out front, so we could drop these parentheses. So we have 20v squared minus 9v cubed. Now this negative sign, once again, we have to distribute that in. Okay, when you distribute a negative sign into these terms here, it's going to switch the polarity, or it's going to switch the signs. It's going to switch them. So here we had a positive 7v cubed. Okay, when you put this minus sign in, it's going to switch it. So instead of a positive 7v cubed, now we have a negative 7v cubed. Okay, here we had a negative 10v to the fourth power. Okay, now instead of a negative 10v to the fourth, now we're going to have a positive 10v to the fourth. Okay, here we have a negative 14v squared. Negative 14v squared. Okay, when we distribute this minus sign in, it switches. Now we have a positive 14v squared. Okay, so when you distribute a minus sign in, it changes the signs. You see that? Negative, now it's a positive. Negative is now a positive. Positive is now negative. Okay, now combining like terms. Let's see, we have 20v squared and we have a 14v squared. Okay, we have a negative 9v cubed and a negative 7v cubed. Okay, and then that 10v to the fourth is kind of all by itself. So here we have 10v to the fourth. Okay, 20v squared plus 14v squared. Okay, Okay, that's going to give us a positive 34v squared. And negative 9v cubed minus 7v cubed. Negative 9 minus 7 gives us a negative 16v cubed. Okay, putting these in descending order, we have 10v to the fourth minus 16v cubed plus 34v squared. All right, you've made it to the end. I just want you to remember that when you distribute a negative sign into a polynomial, that it changes all the signs. Okay, whatever's positive turns to negative, whatever's negative turns to positive. Okay, that's kind of the takeaway from this lesson. So I want to thank you for watching. Please hit the like button if you want to leave a comment down below, and subscribe to my channel for more videos. Thank you.